All right, let's talk about one of the biggest headaches for green energy. You just can't count on it, or can you? Today, we're diving into some really cool research that's using AI to tackle that unpredictability head on, and the results are pretty amazing. Let's get into it. So, first things first, we need to understand the concept of a microgrid. The easiest way to think about them is like self sufficient little energy islands. It could be a university, a hospital, you name it. They can generate and manage their own power, and they can either connect to the main grid or, crucially, run all by themselves. It's a huge deal for creating a more stable energy system. And that right there is the million-dollar question. These microgrids are awesome, and they're perfect for renewables like solar and wind. But what do you do when the clouds roll in or the wind just dies down? How do you keep the power flowing smoothly when your source is, well, as fickle as the weather? That's the challenge. Which brings us right to our first section, the grid's big gamble. Because honestly, without a way to predict what's coming, relying on renewables can feel a little bit like rolling the dice. I mean, it's a simple truth, right? Solar panels and wind turbines don't have an on switch. Their output goes up and down. And this isn't just some small inconvenience. Those fluctuations can cause serious problems for the entire grid, messing with voltage and frequency. To really make green energy our primary power source, we have to figure out how to manage this instability. So how do we do that? Well, the answer is to get really, really good at predicting the future. And that's what our next section is all about, the quest for prediction. For a long time, we've used these traditional forecasting methods. They're based on simpler statistical models, and they're okay, but they really struggle because weather is just so incredibly complex and chaotic. This is where machine learning comes in and completely changes the game. AI models can chew through mountains of historical data, finding these super subtle patterns that older methods would totally miss. The result? Way, way more accurate predictions. In this particular study, the researchers pitted two AI heavyweights against each other. First up, you have the LSTM model. Think of it as the AI with the long memory. It's fantastic at recognizing patterns that play out over extended periods. Then you have the 1D CNN. This one's a specialist. It's incredibly fast and efficient at spotting short-term local patterns in data that changes over time, like the energy output from a solar panel during the day. So, we have our AIs. Now what? Well, you can't just unleash them on the world. You have to train them. It's time to see how you go about training the digital weatherman. And this is the part I love, because it's not some abstract simulation. The researchers used years of real-world solar power data from the microgrid at UC San Diego, and they paired that with all the corresponding weather data from the nearby airport. So these models were learning from the real deal, not a textbook. But you can't just throw raw data at an AI and expect it to work. You have to be clever. Take wind direction, for example. We know that 360 degrees and 0 degrees are basically the exact same direction, right? But to a computer, those numbers are at opposite ends of the scale. This kind of cyclical data can totally trip up an AI. So check out this brilliant fix. Instead of just giving the model a single number, they converted the wind data into a wind vector. They basically broke it down into its X and Y components. Suddenly, the AI can see that 360 and 0 are right next to each other, and it can understand the wind's direction and strength in a way that just makes sense. They did a very similar trick with time itself. An AI doesn't automatically know that Tuesday comes after Monday, or that midnight is right after 11:59 p.m. So they turned the daily and yearly cycles into these smooth, repeating sine and cosine waves. This gives the AI a natural, continuous sense of time, so it can actually learn all those daily and seasonal patterns. It's just really smart data science. All right, the models have been trained, the data's been prepped. It is time for the main event. Let's find out who wins the title of the champion forecaster. So the big question is, after all that prep work and clever engineering, did it actually pay off? How well did these AIs predict the future? Okay, the results here are honestly pretty staggering. Look at that top line. The repeat baseline model, which is just a dumb guess that tomorrow will be the same as today, had an accuracy of about 9%. Pathetic. But then look at the AIs. The LSTM model jumped all the way up to almost 89% accuracy. And the 1D CNN model, it just barely edged it out, hitting almost 90% accuracy. That is a colossal improvement. And it wasn't a one-off. When they tested the models on brand new data they had never seen before, the 1D CNN was the consistent winner. It had lower errors and higher accuracy across the board. Both AIs were great, but the 1D CNN was clearly the champion.
But, and this is maybe the most important part, accuracy wasn't the whole story. The 1D CNN model was also 3.5 times faster to train than the LSTM. Think about that. That kind of speed isn't just a nice bonus. It's what makes it possible to use this for real-time adjustments on a live power grid. It's a total game changer. So, let's zoom out and look at the big picture. What does this all mean for us? Let's talk about powering a greener future. Look, this isn't just about some cool tech or an interesting science experiment. Having forecasts that are this accurate and this fast is a fundamental piece of the puzzle for a world running on clean energy. It gives grid operators the confidence to know what's coming, which makes the entire system more stable and reliable for everyone. So when you boil it all down, what's the real impact here? Well, first, it makes the grid way more stable. Second, it means we don't have to rely as much on those dirty, expensive fossil fuel plants for backup power. That in turn means we can integrate even more solar and wind into the system. And finally, as we saw, it's efficient enough to actually work in the real world for those split-second decisions grid operators have to make. This research really does light up a path to a much more stable green energy grid. And it leaves you with a really fascinating thought. If AI can help us predict and master something as complex and chaotic as the weather for our energy needs, what other incredibly complex systems are we on the verge of figuring out next?